Give you guys 20 seconds to write that down. Multiply multi-digit decimals. Multiply multi-digit decimals. All right. So, first of all, there's a couple things that you need to remember. Do not. Rule number one. Rule number one. Don't worry about the decimal. I'll be out of your way until the end. So basically what I'm saying is, just do regular multiplication. You're just going to do regular multiplication and you don't have to worry about anything until the end. You don't have to worry about anything until the very end of the problem. So when should I worry about adding my decimal? At the very end. I'm going to worry about adding my decimal at the very end. Remember yesterday I set up two problems. I'm going to set up two problems again. I'm going to have 3,456 times 21. Go ahead, write that one down. Here's and don't forget to write that as an example. 3,456 times 21. And on the other side, I'm going to write 3.456 times 2.1. Everyone sees that we have the same digits, right? That's fine. Remember what I said in addition and subtraction? That's the only time you're going to worry about the decimals lining up. The only time you're going to worry about the decimals lining up is when you're doing addition and subtraction. In multiplication and division, your decimals do not have to line up. Your decimals do not have to line up. Does that make sense?
No. Yeah.
Okay. Also in the corner, put this. Addition. Addition. Put, line them up. In the corner, put addition, line them up. Put subtraction, line them up.
Wait, what? Hold on. So you got the decimal and the 2.1 all the way up there. Yeah, that's what I'm saying.
Multiplication, do I have to line up my decimals? No. Multiplication, what do I do? Wait until the what?
Wait to the end.
End. No, wait till the end.
Why do you got the same problem just with decimals and one with complex?
Because I'm going to show you the reason why I have the same problem, one with decimals and one without decimals, is because I'm going to show you that the math is going to be the algorithm. Who remembers what algorithm means?
The process.
The process, perfect. The algorithm is going to be exactly the same. You're not going to change up how you multiply. Only thing you're going to do at the end of this one is count how many numbers are behind the decimal. Right, perfect. That's good. That means that you guys are on track to passing your very first test. All right, so I'm going to go ahead and put this up here so I have more space. Yeah, absolutely. Here we go. Same problem basically, except for decimal points. Here we go. 1 times 6, I'm going to start right here. I'm going to start right here with my very first digit on the bottom. I'm going to multiply my first digit on the bottom times every number on top. 1 times 6. 6. 1 times 5. 5. 1 times 4. 4. 1 times 3. 3. Now I'm going to start with my next number, which is what?
2 times 6.
2. 2 times 6. 12. Carry my 1. 2 times 5. 2 times 5. 10 plus 1. do it, but if you need to put a placeholder there, you can.
I put X.
Okay?
X.
You put X? X works. X works too. Somebody said they put an X right here. That's fine. If that works for you, that's a great strategy. Alright, next one. 2 times 4.
8.
8 plus 1. 9. 2 times 3. 6. Now what are we going to do? Addition. Alright, 6 plus 0. 6. 5 plus 2. 7. 4 plus 1. 5. 3 plus 9. 12. Carry my what? 7. So what's my answer? 72,000. Now watch this. It's going to be the exact same thing for this problem here. It's going to be the exact same digits for this problem too.
72.5.
So we got 3.456 times 2.1. Clap once if you can hear me. Not twice if you hear me. Not 3 times. Perfect. Everybody still with me?
Yes.
All right, cool. It's going to be the exact same numbers. The only difference is I'm not going to worry about decimals until the very end with multiplication. Remember, addition, line them up. Subtraction, you need to line up your decimals. Multiplication, do we need to line up our decimals?
No.
No. You wait until the end. All right, here we go. We're going to do the exact same problem. I'm going to start with my ones place. Well, this isn't really the ones, it's the tenths, but we're going to think of it as the ones place. So I'm going to start with my 1. I'm going to take 1 and multiply it times everything on top. Everybody understand?
Yes.
All right, so 1 times 6. 6. 1 times 5. 5. 1 times 4. 4. 1 times 3. 3. Everybody see? Everybody see how this one is exactly like this one right here? Perfect. What are we going to move to now? The 2.
Oh, I get it.
So 2 times 6.
12.
I'm going to move over because I'm going to put it underneath my 2. This represents going to the next place value. So I'm going to put my 2 right here, carry my 1. Now 2 times 5. 10 plus 1. 11. Put my 1 down, carry my 1. 2 times 4. 8 plus 1. 9. Now 2 times 3. 6. Wait. My digits here are the same as my digits there. Right? So nothing's changed. It's still the same problem. No. Now what do I need to do? Add 6 plus 0. 6. 5 plus 2. 4 plus 1. Wait. This answer is the exact same as this answer. Everybody sees that? Now, am I at the end of my problem? Have I figured out my answer? As far as my digits? Yes. So I waited until the end. Now I'm going to worry about the decimal. What I'm going to say is, how many numbers fall behind this little point right here? Is this 4 right here behind this decimal?
Yes.
Yes. There's the decimal right there. Clap once if you hear. Clap twice if you hear. Clap 3 times if you hear. Is this 4 behind that decimal? Yes. What about this 5 right here? It is. What about this 6? Yes. What about this 1? Is it behind this decimal right here? So how many numbers total are behind? 4. So I'm going to start right here. And I'm going to go 1, 2, 3, and what? 4. So the only difference is this time I'm doing my same math, but after I finish, I'm going to count how many numbers are behind decimals. It can be 2 decimals. It is going to be easy. It's going to be very easy. Remember, don't get too confident. It's the beginning of the year. Remember that beginning of the year assessment you guys got, and how much you guys are like, oh, I don't know how to do this. I don't know how to do this. Don't get too confident. All this 6th grade isn't that easy. So, how many numbers are behind the decimal? 4. 1, 2, 3, 4. What's my answer? 7 and 2. Remember, say the whole number. 2,576. What place route is this?
10,000.
10,000. So 7 and 2,576 10,000s. Everybody understand that?
Yeah.
All right. It's addition, subtraction, and multiplication. All right. All right. So now.
Wait, no, erase it.
I'm not gonna erase it. I'm gonna give you guys time. I promise. I'm gonna give you guys time. So remember yesterday he started on multiplication, and then I stopped the video. I'm gonna keep the video going. As soon as you guys are done copying down, I'm gonna give you guys 1 more minute to copy this down. You guys can talk amongst each other. I'll give you 2 more minutes to copy this down. You guys can talk amongst each other.
All this?
Well, the notes. You guys can talk amongst each other if you're done. I'll tell you what. Next week when we take the NWEA, I don't really do movies in class. If everybody can grow at least 10 points on NWEA and show me that they're growing throughout the year, we'll have movie days towards like May and stuff. But everybody's gonna grow on the NWEA. Alright, so here we go. I'm going to go ahead and I'm going to play that video. Just make sure you take notes on anything that you find interesting that you may not have caught when, yeah.
Move on to something a little harder, decimal multiplication. The decimal point, and you have your answer. Okay, so decimal addition and subtraction are pretty easy. Let's move on to something a little harder, decimal multiplication. Now, as you know, multi-digit multiplication is more complicated because there are so many multiplication steps. But the good news is that decimal numbers don't really make the procedure much harder than it is with whole numbers. That's because there's a clever way that we can make decimal multiplication.
Remember I just said that the procedure is just the same. The process, the algorithm is exactly the same. The only thing that changes is you count at the end how many spaces are behind the decimal. Or how many digits.
Multiplication look exactly like the multi-digit multiplication with whole numbers that you already know how to do. The key is to pretend that the decimal points are not really there.
Hey, when you say the key is to what? Pretend like what? Pretend like the decimal points aren't there, just like I said. Pretend like the decimal point isn't there. Do your multiplication the exact same way you would normally do it.
Hold on a minute. I mean, I like pretending as much as you do, but if we just pretend that the decimal points aren't even there, we aren't going to get the right answer. Are we? Well, no. But the only thing that will be wrong with the answer is that the decimal point won't be in the right spot. So we'll need to fix that at the end. I know it sounds a little confusing. So here's an example that should help you understand. I knew you would say that. Let's say that you need to multiply 3.65 by 2.4. That seems a little tricky, but what if we just pretend that the decimal points are not there for that? In other words, what if we pretended that the numbers were 365 and 24? You already know how to do that, right? You just follow the procedure that we learned in multi-digit multiplication, part 2, and you get the answer, 8,760. But that's the answer to 365 times 24, not 3.65 times 2.4. So it's time to stop pretending. To get the correct answer for the decimal problem, we've got to understand what's going on with those decimal points and why we just pretended they weren't there. The truth is, when we pretended that the decimal points weren't there, what we were really doing is pretending that they had been shifted until both of our numbers became whole numbers. Remember, the numbers 365 and 24 technically do have decimal points. They're right there next to the ones place. We just don't need to show them since there aren't any decimal digits. So, by ignoring the decimal points,
So what was the explanation? What did he say? He said the decimal points are actually there in 365 times 24. He said, but they're actually what? There were no digits behind it. They're actually shifted. So I might ask you a question on your test about that. I might ask you to explain. Hopefully you were paying attention. On your test on Friday, I might ask you to explain. Hint. For those of you guys that aren't paying attention, I might ask you in a paragraph, explain. Explain this whole process. So, Larry said that the decimals are actually there in 365. Yes, Larry. Larry actually explained that the decimals are there in 365 times 24, but the problem is that they're shifted. They're actually right here. And if you move it 1, 2, and you move it 1, then how many place values did I move those decimals? How many times did I shift those decimals? 3 times. 3 times.
What we're really doing is mentally shifting the decimal points to the right. We shifted the top decimal point 2 places to the right, and we shifted the bottom decimal point 1 place to the right. But doing that changed the numbers. It made the top number 100 times bigger than the decimal version, and it made the bottom number 10 times bigger. That's because every time you shift the decimal point 1 number placed to the right, it's like multiplying by a factor of 10. And that means the answer we got is way too big. It's too big by 3 factors of 10, because the decimal points in our problem got shifted a total of 3 places to the right. 2 on the top and 1 on the bottom. So to fix that, we're going to have to shift the decimal point in our answer the same amount in the opposite direction. In other words, we need to move the decimal point in our answer 3 places to the left. which will make it smaller by 3 factors of 10. So, starting right here, where the decimal point would be if our answer was 8,760, we shifted 3 places to the left, and we end up with 8.760, or just 8.76. And that is the answer to 3.65 times 2.4. That's a cool trick, huh? It means that you can do decimal multiplication just like regular multi-digit multiplication. You start by setting up your multiplication problem exactly like you would if the decimal points were invisible. But don't just erase them, because you'll need them at the end to figure out how many places to shift the decimal point in the answer. Then, keep ignoring the decimal points while you follow the multiplication procedure. Once you have an answer, count up how many places the decimal points are shifted in the problem you're working.
How many place values are they shifted in the problem? 4. Perfect. You guys can
Don't forget, it's the total shift of both the top and bottom decimal points. And then, shift the decimal point in your answer to the left that same number of places. So decimal multiplication turns out to be not too bad after all. But what about decimal division?
Alright.
Yeah,
We will. Miss Morgan's here all day. You can talk to her after class. Alright. What she wants to talk to you about? Alright. So, I got a review sheet from yesterday. Got a review sheet. It's addition. Addition of decimals. First of all, did everybody put their homework in that top bin?
yes.
Alright, put your homework